So if you add the first n odd numbers, if you add the 1 is 1 square. If you add one, the first two odd, it is 2 square, because 1 plus 3 is 4, which is, if you add the first three, 1 plus 3 plus 5, which is 9, which is actually 3 square. So if you take the first n minus n numbers, if you take the first n odd numbers, now how is this the first n odd? You have to understand this. You see, n, let's take n as 1. So this will become 2 into 1 minus 1, which is 1. So this represents the general term. This is the general term for odd numbers. If I take n as 2, it will come 2 into 2 minus 1, which is 3. So 1 has been generated by this. If you put 1 here, then it will become 1. If you put 2 here, it will become 3. If you put 3 here, it will become 5, and so on and so forth. So these are the first n odd numbers. So if these will be the first n minus 1 odd numbers, if these are the n odd numbers, then this is n minus 1 odd numbers. Now the sum of the n odd numbers, the sum of all this is n square. So the sum of the n minus 1 will be n minus 1 whole square. So that's what he does. He says n minus 1 square plus the nth odd term. This represents the sum of the n minus 1 odd numbers. First n minus 1. This is the nth odd number. So if you add all of the n minus 1, this will be this. This will be sum of all first n odd numbers. That will be equal to n square. So we get this relation. Now, how does this relation help us? This relation, if you notice, has got two squares. So and this is an odd number. This is an odd number. So if this odd number is a square, then we can actually, we have found the Bodhyana or the Pythagoras triple. How? He says, I have got first 5 odd numbers is 5 square. So this is what? This is this, and these 4 are this. So this is the 2n minus 1. This is n minus 1 whole square, and this is n square. So this way he's written this like this. Yeah, he's written it like this. So from this I can get these things, the Pythagorean triple. So essentially what it means is that if we take like he has done, uh, 25 is an odd square. So what I can do is I first collect all the odd numbers and end where it is a square. That odd number I should look for is a square. Then this can be written as 5 square. This will be 12 square, because these will be 12 odd numbers before this. This is the 13th odd number. And this will be equal to 13 square, because the sum of the 13. So this way we can do, like I will explain another, like 1 plus 3 plus 5 plus 7, and you go on till, let's say, 49. 49. Now 49 is odd also, it is square also. So it is odd also, it is square also. Now which number is this odd number? So you can just check 2n minus 1 is the general representation of odd number. So this is equal to 49. So 2n is equal to 50. So n is equal to 25. So these are first 25 odd numbers. Now the sum of the first 25 is 25 square. So this also I've come to know, because we know the sum of the first n odd numbers is 20. What about the remaining? What will be this? These will be 24 odd numbers. And first 24 odd numbers, first 20. The sum of the first 24 odd numbers is 24 square. So 24 square plus 49 is equal to 25 square, or 24 square plus 7 square is equal to 25 square. So this I have found a triplet. That this is a triplet, 24, 7 and 25. You can just check that 24 square plus 7 square is 625, and this is also 625. So we have found a new triplet by using this method.